All right, so this is one of the questions I had asked you to do on the cyclic quadrilateral. It will be number 2 on the virtual package, so we'll leave it as that, and then we'll look at the next one after. So again, easier than the example, which is what I would have went through on the last video, and also it was worked out on the virtual package as well. So this one, again, I'm going through this information because it helps for me to go through what it have as well. So in the figure above, O is the center of the circle, and so that means automatically if O is the center of the circle, we have a line going through the center touching both sides, we have a diameter. An angle ADC is 120, ADC is 120. They didn't tell me this information here, but I see in a box in my question, meaning here is 90, because I know once they form a angle with the triangle, it's going to be 90 degrees. And all they want in this first part is the value of x. So I know here is 90. I could put it in if I prefer to see the number. I have this right angle triangle here. So if I could figure out this part, because it's inside my triangle, then I could figure out this, because the angles have to add up to 180, and if I have two angles, add them up and subtract from 180, and I could get. Could I figure out this angle? Well, remember, right now, we do in cyclic quadrilaterals. Do we have a cyclic quadrilateral? Let me check it. All 4 points of my four-sided shape, and again, I'm just highlighting it for you to see. You could highlight it on your paper yourself. I just darkened with your pencil or your pen, or you could just train your eyes to see it, right? But I just highlighting what we're looking at. That's my cyclic quadrilateral there. And the rule for the cyclic, once I have a cyclic, they're going to make you use the rule for it, which is opposite angles add up to 180. So if here's 120 and this opposite the 120, both of these have to total 180. So he give 120 to it. How much more he have to give to make the 180? 180 take away 120, so this angle is 60 degrees. And now, because I have this angle is 60 degrees, a triangle, which is this small triangle inside that x is a part of and x is that I want to find, he put up 90, he put up 60. So out of the 180, we want to buy a pizza for 180. One person put up 90, the next person put up 60. How much I had to put up? So 90 at 60. So far we have 150. So he had to put up the balance to make the 180. 180 take away 150. Again, my answer is 30 degrees, and it was that simple. Once you know the rules though, let me look at the second question that you had to do. And in this second question, again, a lot more going on. It's very similar to the first example that we had, but they give you different information as you'll see. So we'll just go through that information. In the figure above, AC is the diameter, so I have a diameter, meaning if it could form a triangle with that diameter, that's the first thing jumping into my mind one time. If I could form a triangle with that diameter, then nice, I get an extra angle, right? And the center is O, angle ADE is 30 degrees. Let me just see that, ADE, that's where they get the 30, ACB, I'm reading it wrong. ADE is 30 degrees, DAC is 35, DAC is 35, and CAB is 40, CAB 40. And what I want to find is angle ACD, ACD. This is one of the angles I want to find first, and they usually ask them in that order for a reason. And you can see that immediately. I have, because of the diameter, I have my right angle triangle here formed with the diameter, so I know that's automatically 90. 90 at 35, you're allowed to use your calculator. 90 at 35 is 125, so here to make up the rest, but show your working. So here going to be 180 minus 125, so here going to be 55 degrees. Here's 180 minus 125, and you can again show how you get that 125 on your diagram otherwise. So the angle is 55 degrees. I get 2 marks or 1 mark, or how much ever that worth, because like I said, this question is normally worth 6 marks. Out of the 12, that number 9 will be worth. Next one, angle ACB. Same idea. ACB, this is the angle I want next. And just like before, I have a next right angle triangle, because they use the diameter as one of the sides and all points touching the circumference. So that means here going to be 90 as well. You don't have to color up your diagram like this, right? This is just me highlighting, but hopefully as you go along you'll see these. So again, just like before, 90 at 40, both of them put up and we get 130. How much more to make that? 180 take away 130, so this angle going to be 50 degrees. 180 take away 130, So this angle is going to be 50 degrees. And the last part now they wanted is angle DAE. Where is angle DAE? DAE is this little part here. So how am I going to find that? Again, I have different options available to me. So it's up to which one you want to use, but it's very similar to the first one if you notice. So again, if I wanted to use this four-sided shape here that I'm going to highlight in green, so much colors, right? So I'm using this four-sided shape here that I highlighted in green. So that's my four-sided shape here that I highlighted in green. You can see now, right? So we just find out here was 55 in part 1. So we know here is 55. And if this is my four-sided shape, obviously the quadrilateral rules say that these two have to add up to 180. So if you put up 55, here going to be 180. Take away 55. So here's 125. 125 add 30 now is 155. So how much more I need to make more? Complete my triangle, sorry, of 180. 180 take away 155, so this angle is going to be 25 degrees. And again, show your working, so whoever correcting it will know that you didn't just watching somebody paper and get the answer, or you didn't just guess, because you're getting marks usually. If you make a mistake, at least you'll get somebody marks for knowing the rules as well. But that's just how these questions would work. And these are the basic rules. What we're going to look at next is some of the slightly more advanced rules that involve something extra called a tangent.